Alright, today we're going to talk about physics some more with respect to units and significant figures. And I call units a flat world because the world becomes so small that we must be able to work in between our system of measurement in America, the English or Imperial system, and the metric system. And again, the only common thing between the two is time. Seconds, hours, days, weeks, which is set by how the Earth revolves around the Sun. SI units has length measurements, centimeters, meters, kilometers, Imperials, inches, feet, and miles. The great thing about SI and why we use SI most often in physics is that it's set on base 10. It's easier to move between things. For velocity or speed, they have like meters per second or kilometers per hour, where we use feet per second or miles per hour here. Volume, centimeters cubed, which is 1,000 centimeters cubed is 1 liter. We use gallons and inches cubed. And this is one of the big reasons we like SI. They have a mass measurement of kilograms or grams, where I put this little red question mark on the Imperial side. We have pounds for mass and we have pounds for weight. And again, we'll get to this more later, but mass is how much stuff there is. Weight has to do with how much gravity there is. If I weigh 170 pounds here on Earth, I don't weigh 170 pounds on the Moon. The Moon has less gravity. And the metric system has a nice unit for force, newtons, where we have pounds. Finally, like pressure, pascals for SI, PSI for Imperial. One thing you probably want to put in your notes is some of the basic prefixes and powers. And again, some of these you probably know, some you won't. And I put the power here in this column, starting with 10 to the 12th, working down to 10 to the negative 9th. And we start with the prefixes and the symbols. You can find this on the inside cover of your textbook too. Tera is 10 to the 12th, giga is 10 to the 9th. Then we get the ones that are much more commonly used. Mega, 10 to the 6th. And then the ones you probably know in here, kilo for 10 to the 3rd. Hecto, which it doesn't get used that much, 10 to the 2nd. Deci, 10 to the negative 1, again, not used that much. But centa, 10 to the negative 2, like centimeter. Milli, as in millimeter, 10 to the negative 3. Micro, 10 to the negative 6. And the symbols have been all pretty self-explanatory. This is the Greek letter mu, alright, it's a funny looking U. Finally, 10 to the negative 9th is nano. And we get the little n. This is a nice way for us to talk about things. Often we talk about micrometers when we talk about expansion in bridges or things like that. And we'll talk about mega a lot of times when we talk about the strength of steel. So it's a good thing to have in your notes. I'm not going to go really in depth into Sig Figs, but I want to just get the idea here, because we can count how many Sig Figs there are and use that in our calculations. But if I have a rod and I want to measure it with a stick here, and I have 10, 20, and 30, I would argue right now I can make a guess here and looking at this and say, this is 23 centimeters long. It has two significant figures. It has the one I can measure, 20, and the one I guess, 3. Anything else going forward I can't be sure of. But if I take a regular meter stick, it's going to have measurements. Alright, and that might not be great, but then I can see here it's 1, 2, 3, and it's really quite a ways, almost to the 4. So now I can change this to 23 point, how about 7 centimeters. And all of a sudden my accuracy has gotten better. And now I have 3 Sig Figs. And if I subdivide it again, I can have another Sig Fig. As measurements get more precise, the number of digits we have increases. When we use those in calculations, that makes our next number in the calculation more precise. Often, when we do measurements, especially of little things, we'll use a tool like this. And this can give us a lot of Sig Figs. And I blew it up as best I could on the board here. So if I had a pen, or a pin, now I was measuring. And this is in inches, because a lot of times our calipers are in inches, and this is a caliper for a tool. I can measure here. And it starts at 0 when the two teeth are closed. And as I go, this is 0.1 inch, 0.2, 0.3, 0.4, 0.5. So right now I'm sitting at 0.5. And then I can read the dial. And the dial is breaking up to the next two figures. And here I have it pointing to the 13. So I can go 1, 3. And actually, if it's beyond the 13 and not quite to the 14 on the dial, I might be able to even guess the next Sig Fig and have like 0.5135. And I'll try to set it here, and I'll put it up to the screen. And this is hard to see, but again, you get an idea here. And again, now I can say that this has 4 significant figures. Again, we count which measurement has the least number of Sig Figs, and that's all our answer can have. In physics class, I will often ask you to carry all the decimals to the end, and instructions will either ask you to put in Sig Figs or to not put into Sig Figs. And again, physics is the study of our universe, and these are the tools we're going to need to discuss it.